All right, before I show you the first fact, I want to review an old fact from Unit 4 that leads into this. So in Unit 4, we throw a triangle up there, a couple angles. We talked about this angle here, called an exterior angle. You want to remind me how you can find it? In your own words or using my angles? Hi, Alicia.
Angle 2 plus 4.
You add angle 2 and you add angle 4 together. Anybody remember what those angles were called? Remote interior angles. Yes, those were called remote interior angles. So what I'm going to do today with you is, hold on, time out. If that angle 1 is equal to 2 and 4 added together, shouldn't angle 1 be bigger than those two separated? So angle 1 should be bigger than angle 2, and angle 1 should also be bigger than angle 4. If they add up together, they should be bigger than the parts. And that's your first fact. That any exterior angle is always bigger than, what do we call 2 and 4 again? Remote interiors, okay? So any exterior angle is bigger than either of the remote interiors. Here's what we're never going to say, is that you can tell me which angle's bigger between the exterior and the linear pair. Never. Oh, it looks like it. Stop with the it looks like it. It's not going to happen. The only thing you could say the exterior angle's bigger than are the remote interiors. That's it. Don't tell me anything about the exterior angles. Good? All right, let's try it out then. All right, that was Unit 4. That was the one I just showed right here. So let's actually put it into use on number 1. All right, everyone sees the beautiful diagram. I've labeled 8 different angles. I want to see how many angles we can find that are less than angle 7. Less than angle 7. And I'll give you a little hint. There's 5 of them in this diagram that are less than angle 7. And at no point are you going to tell me, oh, this angle's less than 7 because it looks like it. Not because it looks like it. All right, let me help first. Everyone agrees that angle 7 is definitely an exterior angle to one of these triangles up here. Name the triangle. Name a triangle where angle 7 is exterior for. All right, use your 3 letters. Stephen, name a triangle where 7's exterior. Perfect for me. MKL. Awesome. Everyone agrees 7 is exterior for that one. So that means, based on what I just showed you, 7 should be less than the 2 remote or greater than the 2 remotes. So if 7's the exterior, give me a remote interior it's greater than. Boom, up and down. Alicia?
5 and 4.
Oh, okay, you're going to show off and give me both. Thanks for stealing somebody's fire. Yeah, you should be. So 5 and 4. Good? Everyone see that? 7's the exterior, 5 and 4 are the remote interiors. Can't say anything about 6. Don't go there with me. Don't go there. You cannot say anything about 6 and 7, how they compare. All right, good. I called on Steven and he gave me MKL. I believe angle 7 is also exterior for a second triangle in this diagram. Can you find it? Because I want to look at that triangle too. It's also exterior for what other triangle in the diagram, Colin? It's a big dog. Which one? JMK?
Yeah.
Exterior means I extend one of the sides of that triangle and I get. All right, that's not part of 7 though, right?
JKL.
Which one?
JKL.
There you go, the big one. Exterior for that one. Perfect. Everyone see that one? It's exterior. All right, well, what would be the remote interiors? That's bigger than. 7's bigger than this angle and this one because they're remote interiors. Just give me one of them first. We'll start there. Give me one of them, Callie. 3. Awesome. Awesome job. So angle 3. And I believe the other one you're going to have to name with 3 letters. All right, because the vertex belongs to a couple different angles. So angle 7's bigger than 3. And where's the other remote interior here? Name it with 3 letters. You guys are doing great today. Doing great. Jacob?
JKL.
Darn, JK?
L.
L. Got it. Yep, JKL. That one right there, right, everyone? That's the remote interior. But I said there was 5. We got to these 4 pretty quick because they were all remote interiors. 5 of them? Where's the fifth one? JKL was less than 7, right? What makes up JKL? 2n. So if JKL is less than 7, shouldn't the parts be as well? Angle 4, which we already have, and angle 2. Everyone see how that worked? Had nothing to do with being remote interior. Had everything to do with that JKL is less, so are 2 and 4 that make it up. All right, questions? Because you and your group are maybe going to discuss, talk, use your voices, breathe, something that shows me you're alive. To do number 2, now I want all the angles in this diagram that are bigger than 6, and 7 isn't one of them. 7 isn't one, and I will at least give you a hint. There's only 2. There's 2 angles in this diagram that are bigger than 6. Go find them. We'll talk in a couple minutes. Go find them. Just quiet it down a little bit. There's other classes around us. Quiet it down a little bit. Talk to each other here. What's bigger than 6? Use your exterior angle fact I just showed you. What's bigger than 6?
How's that really?
What's bigger than 6? Wow, after so much discussion, I feel so confident that everyone's going to give you the right answers here. Angles that are greater than 6. Greater than 6. And we'll talk why for each one. 7's not one of them. All right, anything? You're confident in? Colin, you and your group? Talking for your group? Go ahead. Angle 8 is one of them. Why? Here we go. Take a look at the big, the big triangle, JKL. Does everybody see that 8 is exterior? And what's its remote interior if 8's the exterior? Yep, 3n, 6. Exterior bigger than the remote interior. Good job with 8. And the final one, which I think is a little bit tougher, but it's there. Sage?
Angle 1.
Angle 1 is the other one. And I know people are like, angle 1? That's not outside. Whoa. It is outside if we're talking about triangle MKL. Everyone see it? Angle 1 is exterior, which would mean it's bigger than 4 and 6, which is the one we were focused on. So even though 1's, I know, inside the diagram, it's still exterior for that triangle. Wow, good job, kids. That was great. Good job. Anything else? You thought that was tough? Wait till you get to this last one here. A little above average question here. All right, in triangle ABD, that's not right. Yours says ABD or ABC?
ABD.
All right, yeah, that's fine. Never mind, we're still good. AB congruent to BC, so hopefully everyone's putting some hash marks on your diagram right now. And hopefully we're at this point in the year where hopefully that's not the only thing you're putting on. Hopefully you look at that and be like, oh, if I'm marking these 2 sides congruent, I should be marking something else congruent at this point in the year, right? So I don't need to I just did, but I don't need to tell you that. What else are you marking on your diagram? After you put those hash marks on those sides, Noah, what else is true? Reflexive. What's reflexive?
The one line, BC. They're the same.
These two sides are equal in triangle ABC. What's across from congruent sides?
Oh, wait.
Act like you've been there.
I don't know.
What type of triangle is ABC?
Okay. Oh, it's an acute triangle.
I know you've been absent a couple days, but two sides are congruent in triangle ABC. What type of triangle do I call that?
Oh,
Begins with an I.
stop.
Isosceles. And then what? Not only are the sides are congruent, but keep going.
The angles.
Across from them. So now tell me where I should put markings.
AC. Angle BAC and angle BCA.
There we go. We all good? Everyone else, yes? That could have been you right there. All good? All right, so I'm just going to mark that angle 1 is congruent to angle BCA. That's what we just marked because we may need that. We may need that. All right, which one is true? Which multiple choice is true? And I'm not going to lead you to it. You can discuss it again if you want. I know there was so much conversation before, but all right, which one of those choices is true then? And again, you're going to use this fact that those angles are congruent and one of my exterior angle facts there we just went over. See what you got. This one's tough. I don't know, even the studs in here might get a little stuck. We'll see. And because it looks like it, it's not going to be a reason. You can do this. Look at the two angles we marked congruent. And remember our exterior angle theorem we just worked on. This is a tough one. And there must have been a reason why I put 3 and 4 in those specific spots and not anywhere else.
Angle 1 is greater than angle 4. This, because BCA is equal to 1, and it's like an exterior angle to this triangle. So we can do that. Because we don't know like this equals these two added. So if 1 is equal to BCA, then this is greater than 4. Because 4 and 3 have to be added to make this. It's whatever, it's what we do.
All right, let's see what we got here. I'm not going to ask for an answer. We're going to get this together here. We just marked angle 1 and BCA congruent. Are either of those two angles exterior angles for any triangle in the diagram? Angle 1 or BCA, are either of those two exterior angles for any triangle in the diagram? That's all I want to know right now. Are they?
Yes.
No? Yes?
Yes.
Yeah, one of them is. Which angle is an exterior one? Which angle? Angle 1 or BCA? Which one's the exterior?
BCA.
Angle BCA. And if you don't see it, look at the diagram. Angle BCA is exterior for triangle BCD. All right, here you go. Take a peek. And there is the exterior angle right there, BCA. Everyone see it? So help me out. Finish this. Angle BCA, if it's exterior, we learned today, should be greater than, name a remote interior to it. Angle 4. And it's also bigger than what other angle in that diagram if it's exterior? Angle 3. So is everyone all right with those two statements and why? All right, now how do I get to my final answer? Well, if BCA is bigger than 4, and we already said at the beginning BCA and 1 are equal, that means guess what other angle has to be bigger than 4? Angle 1. Also, angle 1 is bigger than angle 3, but only one of them is a choice up there. So does everyone see that? BCA is bigger than 4 and 3, so that means 1 is bigger than 4 and 3 because they're equal. See how that worked? Ooh, that was a tough one, huh? Any questions about exterior angles being bigger than the remote interiors? All right, the second and final fact for today. Do me a favor before we start. Find the missing angles in your triangles. I know my triangles look a little different, but we have the same values up there. Find the missing angles for me. Find the missing angles. And you are legitimately going to have to discuss this with your group. All right, everyone's got the 42 degrees filled in triangle 1 and 35 degrees filled in triangle 2. All right, I'm going to give you about 2 or 3 minutes right now. There is a pattern in each of the triangles between the angles and sides. All right, so I want you to look at triangle 1, look at the 3 angles and the 3 sides. There's a pattern there. Triangle 2, same pattern exists between the angles and the sides. What is that pattern? Okay, don't overthink it either. I don't want this. Well, I'm going to take 3, multiply it by 8, subtract 15, and I get another side. That's not what I'm looking for. All right, that kind of pattern. I'm looking for, look at the angles and the sides, where they're located, angles and sides, and see if you can come up with a little pattern that fits for both triangles. Because that's going to be my second fact today. Discuss! Woo. And your rule has to work for both triangles.
Like the side that's opposite. Oh, okay. Yeah. Yeah. It's like 3 and 42. Yeah.
See anything? There's got to be something here. Lillian?
The greatest angles are opposite from the greatest sides.
What's the biggest angle in this diagram? 82. Look across from it. What side is it across from? 7, which also happens to be the largest side. Also, what's the smallest angle in this diagram? 42. What's it across from? 3, the smallest side. Does that work over here too? 105 is the biggest angle. What's it across from? 25, which is the biggest side. See how that worked? That is correct. All right, so let's write that down before we discuss it more. So in a triangle, we always have to have that because none of these facts work in quadrilaterals, pentagons, octagons, only in a triangle. The biggest side is across from where's it always across from? The biggest angle. Boom. Biggest side across, and then we could also substitute in the word smallest side, smaller angle, smallest angle. Look good? So here's what we're going to do to finish class. Calculation problem, algebra problem, and then I'm going to blow the roof off this place. All right, with the 2 problems at the end. All right, let's start with calculation problems. List each side from shortest to longest. Well, not going to be able to do that until you find angle B, huh? All right, not going to do that till we find angle B. And let's make sure we're all in agreement before I ask somebody to rank the sides. So angle B, 92 degrees. All right, rank them. Shortest to longest. Smallest side across from smallest angle. So start with me here. What's the smallest side in that diagram here? Smallest side in that diagram. Where am I going with that one? Noah, come on, redeem yourself. Smallest side. BC. Next smallest side, BA. And then the longest side ends up being CA. There you go. Good ranking. We all right over there, Goof Troop? We good? Okay. Put your brains together. You might get one, right? We're good over there. We good? Too harsh? Not thick skin over there in that group? I hear you busting Colin's chops, so I think the rest of you three can handle it too, right, Colin? Okay. I'll stick up for you. And then number 2, nobody's ranking anything till I know the angles. Is everyone comfortable finding the missing angles there? 107 and the one next to it, supplementary. November 25th. Hopefully we're good. 73. And that would make angle T 32. Rank them. Smallest side. Let's do this. 1's Jacob's smallest side. SR. Next smallest side. ST. And the largest side. You got it. All good with ranking them, given the angles. No problems? All right, now let's go to algebra. If you want to draw a diagram here, feel free. If not, that's fine too. I am going to draw a diagram just to help you guys out. Triangle ABC is your vertices. And it's looking like they're giving us all 3 angle measurements. So you want to, maybe you already know what to do with them. Maybe you need a diagram to see what to do with them. It's totally your call. And now it's asking me which one of these is true. As we look through the choices, like is it isosceles? What's the longest side? Is it obtuse? I'm going to have to know the angle measures. Without a doubt, I'm going to have to know the angles. So to start, I got to find x. Equation you want to set up to find x so I can substitute back in. Bella?
3x plus 4x minus 19 plus 3x minus 1 equals 180.
There we go. I don't know if it was in this class or not on your quiz, but sides don't add to 180. Stop with that. It's only the angles that add to 180, not the sides. All right, solve for x. When you have x, let me know. If you haven't gotten it yet, take your time. No rush. When I go with this one. Ashley, when you have x, let me know.
20.
20, yep. Everyone's getting 20 for x.
Yep.
Please substitute it back in. Please substitute it back in so I can look at these angle measurements and answer the question. Steven, when you have those angles, please let me know there, young buck.
Angle A is 60 degrees.
Darn right it is.
Angle B is 61.
Darn right.
And 59.
Way to finish. All right, so I have all 3 angles. You ready to answer the question now? Is this isosceles?
No.
Nope, because it should have 2 congruent angles, and it does not. Let me jump over to number 4. Is this obtuse? Is it an obtuse triangle? Nope, because none of the angles are bigger than 90. That's what obtuse would mean. All right, now it comes down to which side's the longest. All right, what's the biggest angle up here? What's the biggest angle? 61. Look across. You got the biggest side, AC. All right, buckle up. All right, now it's going to get pretty intense, these last 2 problems. This figure, which segment is the longest? Well, good. I see people go into their calculator. I can't even start discussing this with you unless I know all the angle measurements in the diagram. So go ahead and find all the missing 2. $60 and $57 look good. I understand what a lot of you might be thinking based on what we've just done. Oh, you want the longest side? I'm going to go to the biggest angle, 70, look across. There's my answer, BC. No. Here's what you just did. You gave me the longest side in BCD. What if there's a longer side in ABD? Because I want the longest side in the entire diagram. So me saying it's 70, look across, there might be a bigger side in the other triangle possibly. So I'm not just going to assume that it's going to be B. It might be, but it might not be because there might be a bigger side in the other triangle. Make sense? So how are we going to figure out where the biggest side is? We're going to rank the sides in each triangle right now and look at our rankings. So let's start with triangle ABD. And when I do rankings, I always like to rank from shortest to longest. That's how I roll. So that's how you're going to roll right now. ABD, go from shortest side to longest side, and I'll write them down as you tell me. Shortest to longest. Callie, let's do this. What's the shortest side in ABD?
Shortest side is AD.
AD, good start. Next shortest side?
AB.
AB, good. And then that makes what the longest side in that triangle? BD, good work. All right, so there's that triangle. And we're going to put it up against the sides in triangle CBD, everyone. Let's rank the sides in CBD for me. Ashley, you're up. Smallest side?
BD.
BD. Next?
DC.
DC. And the biggest side?
DB. BC.
BC. All right. All right, everyone go with the rankings before we talk. Take a deep breath here. Take a little break here before we look. We're trying to find the longest side, right? So look, it's got to be a battle between the 2 longest sides in each of the triangles. It's got to be a battle between these 2. One of those 2 has to be the longest side because they're the longest sides in each triangle. Look at your rankings right now. There is no shot logically it can be one of those 2 sides. No shot. Look at your rankings right now. You went from shortest to longest in each of the triangles. Out of these 2 sides, there's no shot it can be one of them based on what you ranked. Which one can I confidently eliminate based on your rankings right now? There's no way. I'm looking at my own rankings and I'm like, there's no way it can be that one because I did this. Ryan? No shot at BD. No shot. Why? Look at your own rankings. Didn't you just tell me BD was the what of this triangle? Shortest side. Look. There's 2 more that are bigger than BD. So how can BD be the biggest overall? Make sense? It cannot be BD because in your darn rankings, you rank DC and BC bigger than it. So the longest side ends up being BC. And I get it. Oh, it was across from 70. Okay, well, watch, ready? They tell me you're above average math students in here. Debatable. Just joking for some of you. Let's do this then. Let's rank all the sides now as one. We already said BC was the biggest. Look at your rankings. What would be the next biggest then? Do I automatically go to BD? Is BD now the biggest now? No, because what did you rank bigger than BD? Okay, so that's next. Now what would be next? Now what would be the next biggest side out of the 3 I have left? BD. Now out of these 2, what's bigger? Look at your rankings. What's bigger? AB. And what would be the shortest side overall in this diagram? AD. And I'm asking you to do this with me. Look at the diagram. What's the smallest angle in that diagram? The smallest angle? 53. And what's it across from? Was BD the shortest side? That's why you can't do that when you have two triangles put together. You can't just say smallest angle, smallest side. Because look, it wasn't even close to being the smallest side. It was AD. All good? All right, one more because this one doesn't make you great. Trust me. Fill it in. We're looking for the shortest side now, the shortest side. And we already know it might not be across from the smallest angle. So fill in the angles, rank the sides from shortest to longest, please. Fill in your angles and rank them from shortest, smallest side to biggest side. And then we'll look at all of our rankings to see which one's the shortest overall. You can do this. Whew. See if you before I start talking, see if you can take a look. See if you can predict which one's going to be the shortest one before I start talking. You've already determined what are the two smallest sides in each triangle, so it's going to be either one of those as your answer. But one of them does not make any sense. Everyone have them ranked? All right, let's talk. Let's go to the two shortest sides in each triangle, which are YA and VA. All right, I know my answer is going to be one of those two because they're the shortest in both triangles, but according to my rankings, one does not make any sense logically. No shot. Doesn't make any sense to me. Which one can I eliminate up here, Colin?
YA.
I can eliminate YA because wasn't YA the biggest one in the other one? So how can it be the shortest overall if it's the biggest one in the other triangle? And I've already ranked two that are smaller than it right here. You told me in your rankings these two were smaller than YA, so there's no way YA can be the smallest overall, so it's got to be VA. Okay, VA. Questions? Last thing, I just want to warn you tonight so nobody skips it because it seems too tough. There will be a question tonight on the assignment that you're about to start where it's going to give you coordinates of a triangle. I'm just making this up so I can go quick. Okay, it's going to give you coordinates and it's going to say rank from shortest to biggest the angles in the triangle. From smallest to biggest, the three angles. Now you're not going to go by the looks of it. What did we learn today? Where's the smallest angle located? Across from? Smallest side. How will you determine what the smallest side is? How?
You have to find
Thank you. That's what we're going to need. I'm going to need to use what? So here it is if you need to jot it down. Kind of like when some of you walk in the room. That's what I feel like. All right. Too bad you're not absent. Cry me a river. All right. So you will need the distance formula for that one to figure out what the biggest side is, and that'll be across from the biggest angle, and you can go from there.